Hi, my name is Tabitha Awanda and you're watching InterSTEM, and today I'm going to be interviewing Nishanth Kumar. He's a junior at Brown and I may not do enough justice to his intro, so I'm going to have him take it from here and tell us a bit more about who he is.
So my name is Nishanth. I'm currently a junior at Brown, as Tabitha said. And for my entire time at Brown now, and for a little bit in high school, I've been a researcher interested specifically in robotics and artificial intelligence. I've had the good fortune to join a great lab at Brown Robotics and work closely with professors and graduate students to publish a bunch of papers. And I'm super excited about the field and hope to continue being a researcher and going to grad school and all that good stuff.
Awesome. So the last time you spoke, I realized that I'm a computer science major and you're a computer engineer. Well, in the making. So what's the difference between our fields? Like, how would we distinguish them to a layman?
Yeah, that's a great question. So computer science is focused, I guess, on what people traditionally consider programming. So it's focused on developing algorithms and, using math and various other tools to develop programs. So very much on the software side. And at a high level, computer engineering is similar. There's a software focus, but there's much more of a hardware focus. So computer engineering is all about how do we build better computers, processors, and things that might be useful in the context of building robots, or when we need to accelerate our algorithms much faster than they currently can with software, then we build dedicated hardware for it, and that's sort of the realm of computer engineering.
Nice. So you dropped in a little bit of how that's tied into robotics as you were answering my question, and now I'm just wondering, how did you get started? Like, what piqued your interest in robotics, and how are you continuing that right now at Brown?
Yeah, that's a great question. So I actually got started, as with most, I guess, 10-year-old boys, I thought robots were cool, just like cars and other things.
Yeah.
So I'm an international student. I come from a small town called Coimbatore in India. And in the 6th grade, there was this professor from one of the UC colleges in California. He was a professor of mechanical engineering who decided to hold a robotics camp at my school. And this was around when Lego started releasing their first robotics kits.
Okay.
And so he spent a couple days walking us through what a robot was and how to build them. And at the end, we had this competition where you would have to build a sumo wrestling robot that would fight with other people's robots. And it was best thing a 10-year-old boy could see. It was so exciting. And I've been pretty much hooked ever since then. So after the 6th grade, I got really involved with, we started a robotics team at my school, and we started competing at robotics competitions for middle and high schoolers. And every year since the 6th grade, I was part of some team that was doing some competition throughout the year. So we would do many different competitions because the seasons are different.
Yeah.
So got into it, got really interested. We were pretty successful in India. And then when it came time to consider college, I knew, this is something that interests me. And the best way, I guess, to get access to it is through research. So as I was deciding on what college to attend, I was looking up, are there research opportunities for undergrads? Are there cool people doing work with robots that would be interesting? And I saw Brown has Professors Stephanie Telex and many others, and a large group called Brown Robotics, where a lot of undergrads get to do cool work. So that was part of the reason I decided to come here. And, my first couple days here when I was a white-eyed freshman, who didn't know anything, I just sort of went into the robotics lab and, knocked on the door, said hi to a grad student and said, hey, I have no idea. I have some experience, but I don't know what research is, but it seems kind of cool. And that's how I got involved. And it's been, honestly, one of the best one of the best experiences at Brown and just in my life in general. Being part of the lab means a lot to me, and I've continued to try to do that ever since.
That's amazing. And I'm picking up a couple of like themes from what you just said. The first is that like you're very proactive. There's a lot of competitions that you did like on your way like to Brown, but I think even the fact that you were a freshman and you went into a field that you weren't really sure about. You said you walked into the place and you're like, hey, I don't know what I'm doing, but I'd like to be involved. That's really cool, and I appreciate you for that.
Thank you. Yeah.
What advice would you give a student who's looking to join a research program but is not sure that they're well equipped enough to be a part of those teams? How would you advise them to approach the imposter syndrome that comes with that sometimes?
Yeah, so imposter syndrome is definitely real. It's something I deal with a lot. The professors and grad students conducting research at anywhere are just, when you go in as an undergrad, they're just miles ahead of you in terms of what they know. But I think I've learned a couple things so far as a researcher, which is, one, I think it's really important to always take a step back and realize that everyone who you currently think is, so knowledgeable, all your professors, all the grad students in the lab, all of them were you someday, like in the past. All of them were this, wide-eyed freshman that, got a research opportunity in a lab, liked it, and then continued that, and that's how they got to where they are today. And in my experience, professors and grad students uniquely recognize that, and so they're always willing to mentor and help and so on. So that's definitely one thing that helps. I think another thing that really helps is I've spent a lot of time attempting to study just successful researchers, but also successful people in general. And it's not necessarily, I think, about how much you know, but rather how much you try. So as long as you go in with the attitude that, you're always willing to learn, you're always willing to try to get better and improve your knowledge, then it's an interesting shift between, this is a competition to this is a learning experience for me, and I get to be in this environment where people know so much more than me, so there's potentially a lot of growth, and I think that's cool.
Yeah.
And finally, something I've really observed in a lot of the projects I've been a part of is that undergrads are uniquely valuable to research. Just because it's very easy in research for people who know a lot to get stuck in their heads.
Yeah.
To think of an idea and then be like, oh, this is the greatest thing ever. But it's really complicated and needlessly so. And lots of times, myself and other undergrads who are involved in research will ask, what seems like a stupid question, or will bring a perspective from someone who isn't as, neck deep in the field as these grad students or professors, and that can be really valuable, in formulating ideas and working on projects. And above and beyond that, writing and communicating research, I think, is a super important part of being a researcher. And as an undergrad, you come from, the average reader. The people who are reading your papers aren't going to be as neck deep and expert in the field as you are. And so it's very helpful for undergrads to be involved in the writing and reviewing process of research projects, because they tend to give a perspective that leads to better communication.
Awesome. That is a lot of things encapsulated into one amazing response. And I'd just like to pick it apart a little.
Yeah.
You talked about your professors and the grad students working in the same lab, having a mentorship approach to the undergrads. My follow-up question is, how do you maintain a healthy mentor-mentee relationship so that both of you are growing from that relationship?
That's a great question. So I think it's important to just, first of all, acknowledge that, that is the kind of relationship you have. There is a mentor and there's a mentee. There's someone who's more experienced and there's someone who's less experienced. And just, know that, and with that in mind, keep asking questions. I think, these people, professors, grad students, they're in the field because they love it so much. They're here because this is what they want to be doing with their lives, regardless of anything else. So they're always happy to talk about it and and answer questions. So I really think one way that it's like healthy and good is to just keep asking questions anytime you want, and just you'll be surprised how much they'll just start talking and how much you can gain from that.
Yeah.
I also think it's something I really try to do is cultivate like a lot of appreciation and gratitude. So I like to, when I've been mentored by like professors and grad students, I like to like, after project is done, or if they've said something completely helpful, like super helpful, I like to send out like emails, or like maybe write a handwritten letter or something saying, hey, like, you may not have realized this, but this, like, what you said to me, or like how the fact that you like were even willing to like talk to me and mentor me has meant a lot, and like it's changed my life. Thank you so much. It means a lot, that sort of thing. And I think they get a lot out of that, and that helps, the relationship grow further.
Awesome. So I'd like to delve into the more technical side of this interview, where we talk about what you do here at Brown. At the conference that we met at, we were talking about the use of AI and machine learning in the betterment of robotics. So could we delve into that and talk about how machine learning is currently being used to improve the state of the robotics?
Absolutely. So I really think, and I sort of mentioned this in my talk at the conference, there's each of these fields can really feed off of each other. So robotics really improves through machine learning in many ways, and machine learning improves through robotics. And currently, there's a lot of, hey, let's use machine learning to improve robotics, and that's very present in the field. So there's been a lot of excitement of like modern techniques like deep learning and reinforcement learning. When you put them on a robot, you can do some impressive things, get impressive demos, and that's been a lot of excitement in the community. But I think the other direction is also super important, and that's something I try to work on as well. Robotics poses very unique challenges because robots act in the real world. Most of our machine learning and current AI algorithms, they're designed with sort of a disembodied agent in mind. So, something that's operating in simulation, maybe over images that we give it from the internet or things like that, operating in highly controlled environments that we can curate for. The real world is super messy, and it's a much harder environment with lots of things that can potentially go wrong. And so when you try to take these algorithms as they are and apply them directly to robots, you realize that there's so many issues, like they just don't work. And that's amazingly interesting and useful, right? Because now, by having a thing that interacts with the real world and encounters all these problems, such as, oh my God, I can't assume that if I go forward, move my wheels forward, I will actually go forward because, maybe I slip, or maybe the power isn't going to my wheels, or like there's all these issues. Based on that, trying to improve our machine learning methods. So at a high level, I think there's, sort of two different sort of schools of thought and these were actually proposed by some giants in the field. In like the 1970s, when everyone was thinking about how best to build an intelligent computer. So there's one school of thought that says we should solve really hard problems in really simple environments. So, we should build simulations and general and like virtual environments where we can control everything, but then we should solve a really hard problem, such as like image recognition in this simulated environment. Another school of thought said we should solve simple problems in really hard environments. So we should build robots for the real world, but because it's so complex and hard, we should do really simple things. We should just try to make it drive reliably, or know where it is in the world, or do simple things. And so these were two different ways of approaching the problem of intelligence. Do I solve hard problems in simple environments or simple problems in hard environments? And the camp was sort of split between people, and different people worked on different aspects of the problem. And I think what turns out to be the answer is we should really be doing both.
Oh, really?
And we should, by doing both, we learn things here about hard environments, and we learn things here about hard problems, and then hopefully we can build a bridge to hard problems in hard environments.
Wow.
And that's sort of, I think, what's really exciting to me about the state of the art in robotics and AI right now, that we can start to bridge these two schools of thought and these two approaches, and finally maybe reach for actual intelligent robots, which I think has been the end goal the entire time.
Mm-hmm. Wow, that's really impressive. I had no idea of the two schools of thought, but if I were thinking about this 5 years ago, I probably would be in the second school of thought, where it was simple problems, hard environments, because I feel that's a lot more practical. And once you start small, you can keep scaling the size of the problems. But I guess there's other ways to handle it. So could you talk about what you're currently doing at Brown Robotics and how you see your work impacting the field in the future?
I really would hope that my work is lucky enough to impact the field. I think there's a lot that goes into that. So I'm really interested in the intersection between artificial intelligence and robots. And as I was just saying, we're at this time where there's a lot of really cool algorithms that operate in simulation. People use them on robots, but there's a few people, and I'm really excited about using robotics as a way to improve artificial intelligence, and vice versa, and really allowing the two things to feed off of each other. But the other aspect that Brown Robotics as a group is really interested in is, how do we build collaborative robots? Because no one wants to see a Terminator and an interesting thing is that, we can actually learn a lot from humans. Our robots, humans are the sort of gold standard for intelligence. A 5-year-old is able to do more than I can get my robot to do, even with 20 years of, programming it and working on it. And so if we get our robots to collaborate effectively with humans, well, not only are they more practical and useful because humans can, tell them to do things and they can understand, but also we can make them more intelligent by sort of collaborating with humans. So, a lot of human learning, as babies do, comes from observing their parents and other humans and talking with them and stuff. We go to universities to learn from other human beings. So it sort of makes sense that, here's this massive wealth of knowledge. Let's try to leverage that. So my work at a high level tries to focus on how do we, at the intersection of AI and robotics, how do we think about more collaborative robots, but also more intelligent robots. So looking at the intelligence side, and that has things like better algorithms, improvements to deep reinforcement learning, things like that. Mm-hmm. And the collaboration side has things like, maybe we can leverage things like augmented reality or virtual reality or these emerging technologies to enable human-robot communication better. And I really hope that by sort of doing both, we get to make robots that are not only more collaborative, but as a result of being more collaborative, are also more intelligent. And, again, get this sort of thing where we can feed off of two different approaches.
Mm-hmm. And it comes full circle.
It comes full circle, yeah.
Wonderful.
Hopefully.
Yeah.
So as a student at Brown, deeply involved in research and just finding your way through this field of robotics, what advice would you give to a student who is trying to find their way into this field and like who's questioning whether or not they can get their foot in the door?
I think that's a good question, and I have a couple of thoughts about it. So I really think that, especially in college, especially as a student, it's really important to try to figure out, like, explore a lot of options, but as you explore, learn more about yourself and what you like and what you're good at, and then exploit the intersection of what you like and what you're good at. And I think, research and robotics is a super exciting field, is something to definitely try. So as for advice, I would say just email people. Just like blanket, like your university, even if it's another university, just email people. Maybe you'll need to send out like 60 or 100 emails and only like 2 people will reply, but those 2 replies could absolutely change the course of your life. So I think that, some useful things are, there's these things called REUs, which are research experiences for undergrads, and they typically happen over the summer or semester, and you'll see them at like many top-ranked universities, open for application to anyone. So I would highly recommend doing things like that.
Okay.
One, and two, I think the great thing about robotics, artificial intelligence, and computer science in general is that, to work on it, you really just, and to educate yourself, the internet is a magical thing. You really just need a laptop that's like decently able to access the internet, and you can start being an AI researcher. So I think, just generally staying abreast of the field, reading papers. Maybe you understand nothing. I mean, even at this stage in my research career, when I read a new paper, I understand like maybe 40% of what's going on. But that's okay, even professors don't really understand the things they read, and that's exciting and humbling to know. So just, doing everything you can and generally trying to stay abreast of the field, learning buying textbooks, just reading things. One story in particular that I'm particularly inspired by every day is one of my advisors. His name is Professor George Konidaris. Is originally from South Africa. Okay. He didn't really know what computer science was, honestly, throughout undergrad, but he heard of artificial intelligence in the 80s, and he saved up money to buy a textbook. I think he said it was 250 Rand, and it took him like a year to save that up or something. And he bought the AI textbook, and he read it, and then in his final year of undergrad, and he decided that that's what he wanted to do. So he ended up becoming a PhD student after master's for one of the fathers of reinforcement learning, and is now a professor at Brown who has a plan to solve general artificial intelligence, and is one of the most inspiring and like exciting people I've ever met. And it started with him reading a textbook in the 80s as like a random college student in South Africa, and now he's made so many seminal contributions to the field. So I really think that anyone can and should get involved, and if he could do it when the internet didn't really exist, as like a student in a completely different country where there wasn't as much opportunity at the time, then I think that almost anyone can.
Wow, that is a huge challenge posed to anyone who watches this interview, that's for sure. So this is a chance for me to give you, to let you give your parting shot. So what final message would you like our viewers to have?
I think I'll split this in two. I'll give one thing on just my thoughts for the field and like why maybe swaying people a little bit to get interested, and another of just like, general for anyone watching this, what I think and what advice something along the lines of what advice I would give, I guess, to myself or a younger version of myself. For the first thing, I think intelligence is perhaps the thing that is the reason that human beings are, or you and I right now are wearing clothes and sitting in this interesting room instead of in a jungle somewhere, like being scared all the time, not really sure what to do. And how intelligence works is maybe one of the most curiosity-inducing questions of our time. And, we are at a unique time in human history where we have both the tools and the opportunity to study this question of intelligence, but also deploy it to do the amazing things that humans have done with it, but in an automated fashion. And I think an idea like that is incredibly powerful, and it could change the world for the better. And we really want to get this right. We really, really do not want to mess this up. There are quite a few nightmare scenarios that we really want to prevent from happening. And so it takes everyone. It takes perspectives from many different people, and that's why I think, if you're even mildly interested, this is maybe the problem of our lifetimes, and you should get involved and try to contribute. You'll be surprised how much you can do. So that's my pitch for robotics and AI. On the other side, just like general advice in general, I think, I study reinforcement learning a lot, and there's this theory about exploration versus exploitation. So in the beginning, when you don't know too much, you should really be exploring and this can be proved with maps, so we should believe in it. But the optimal thing for you to do is to explore as much as possible. But once you have an idea of what your likes are, what is good for you, you should begin to focus and exploit. And so my advice is follow that model. Start exploring, and then once you have a decent idea, exploit, and cut out the noise of what other people or society in general thinks. What matters at the end of the day is your own feelings of what brings you meaning and what you think and want to do with your life. And focus on yourself, explore, then exploit, and try to cut out the noise as much as possible. And just do what brings you meaning and what you're interested in. I think if everyone on this planet does what they're uniquely interested in and brings them meaning, we could, humanity could start conquering the universe and doing amazing things. And that would be amazing. Thank you guys very much. Thank you for having me, and if you're watching this, thank you. It means a lot. Thank you a lot. I don't know. I'm strapped for words right now, but I don't know. Never been interviewed before, and this is great. So it's a great experience. Thank you so much.
Yeah,
great
thank you.
opportunity.